Hey, so I'm back again. We're at part 4 now, and basically we're just going to start cleaning up the plates here, and I'm going to show you what they're going to fit into. So I've just got my utility knife here, and I'm just going to slowly work my way around and take off the excess silicone here. Now, depending on what kind of magic wizard you are or what kind of application process you personally figure out, you may not have to do this step or may not have to do it very much. Me? Well, I tend to over-applicate silicone when I put silicone. But, hey, as it is, can always be cleaned up. So, another part of the reason I'm interested in these generators and why I'm designing this is because if this is all based on capacitance, then when you increase the radius of your rotor, you should be able to get an exponential increase to the current you're producing because you now have an exponentially larger capacitor. The stuff inside of here is okay, you can leave that. That's not going to interfere with anything. And the voltage that you produce should also be exponential. Or not exponential, it would be linear in relation to the increases to the radius of the rotor. But then the current, because it's all based on capacitance, so the current is now being multiplied by the new voltage from the increase of the radius. But now it's also got an exponent because of the way surface areas work out. And so it seems to me that you end up getting, especially if you insulate things correctly and you make full use of that surface area, it seems to me that by making a larger diameter rotor, it should be relatively quick that you start reaching power production levels that normally you would need a very large electromagnetic generator to be equal to. Now, I'm not necessarily saying that it's going to be easier to spin the rotor. It could still be just as difficult. Probably still need just as big a drive shaft. But maybe we can have very powerful electrical generators in a significantly smaller size package, generating way less heat, simply by running high voltage, low amperage. Actually, this one wouldn't be too bad to take the inside off. I'll leave it for now, and I'll see if it interferes with the drive shaft. If not, I'll leave it. It's I kind of like the way the extra little bit looks. So, this is one half of the case. The other half is printing now. It's got little depressions inside of here, so that when you attach two sections together, there's an area for the screw head to rest inside of. That way, when you put the end cap on, the end cap sits flush. So this is going to fit with the end cap on it. Oh. It's going to fit with the end cap on it. There'll be a second piece that's going to fit as well. The bearing's going to fit inside of there. That's going to fit inside of there. Then we have the disc and the shaft adapter for the disc. Well, a little bit tight, that's a good thing. And that's going to fit on there and screw on there. And now, I'll just use this piece over here. Oh, I missed the side. There's a little bit left. There. So you can see on this piece over here these all these little notches. Well, one of those notches on the inside lining up over here, and I'm going to show how to prep this later. It's going to line up on this side over here. One piece on one side, and all nice and snug. And then the other piece on the other side. And that's all gonna be secured in place with the other side once it prints. And of course, the disc will be sandwiched in the middle. All nice and tight, everything all close together. Now the PLA has a dielectric constant somewhere in the vicinity of 3. And actually I'd probably put the plates on the other side because I would want the side with the nubs to be on the inside. Because the PLA has a dielectric constant of 3. Somewhere around there. Yeah, just like that. And there we go. The gap there for the air between these discs, it's not very big. On the program, it's supposed to be like 2.5 or 3 millimeters. Put it in upside down. It's alright. When the generator is assembled, it's not like it's really going to have an up or a down, and really, as long as you can take the drive shaft out, who cares? So yeah. Anyway, that's it for part 4 of prepping the inductors. And I will see you... Oh, actually, you know what? Before we end part 4, just to give a sense of the overall thickness or size that this generator is going to have. Look at that. That's going to be tight. Let's see if we got this on camera here. Make sure we got this on camera. I don't want to drop it in just yet. I'll have it in with the drive shaft. It's gonna be fun. Alright. See you next time for part 5.